Alright, notes on shifting graphs. So if you finished up take a moment to reflect, you should already have some of these filled out. I know that one class got to it in class. So if not, you might want to spend some time looking at that so you understand what's going on, okay? So hopefully you know that this first function, since it is to the squared, is a quadratic. There we go. This second one, since it has those nice straight parentheses, for lack of a better term, is an absolute value. And then this last one has a radical, so it is a square root function. You do need to know those names, and you do need to know from the name the general shape of these functions. So let's take a little look at these. We're going to come back to A and B, and we're actually going to focus on what happens on H and K first, just because it's a little bit easier to understand, and then we'll get into those guys, okay? So keep in mind, they have these general forms here that are very, very similar. A, B, H, and K are placed in the same spot for all of these, okay? So we're going to look at what H does to our graph and what K does to our graph. So hopefully you know that a quadratic function looks like this. It's a nice U value. And if we change the K value, so right now I have this as A is 1, B is 1, H is 0, and K is 0. So if you plugged all those values in and simplified it, this would just be y equals x squared. So it's just y equals x squared, no big deal. If I change my K value, so it's y equals x squared plus 3, what's going to happen here as K moves positive, this graph will hopefully do exactly what you think it will, and it will move up. So once I make it 3, now this point, which we call the point of inflection, is at V. Sometimes you'll hear this called the vertex as well. Okay, so this is at 3. So K mirrors the y value of this function. So if I make K negative, it is going to shift my graph down. So if I go to -2, it lands on -2. Okay, so just some good stuff to look at, to think of. Okay, hopefully the graph moving is kind of cool and helps you out here. So let's sneak down to our K value. So when K was positive, it shifted our graph up, okay. You're going to hear this called a vertical shift, okay. As well, these are all words you are going to be asked to describe what is happening, so you do need to know these terms. And then when K was less than 0, when it was negative, it shifted the graph down, which was still a vertical shift. So you're shifting in the vertical direction, your y values, okay? So this is going to affect y values, okay? I'll throw that up there as well. Okay, make sure that you pause if I'm going too fast. I was trying to make the video not too long though, okay? Alright, let's look at H. So hopefully, knowing that K moves things vertically, you can kind of deduce that H is going to move things horizontally, but H is a little crazy. If I change my H value, and keep in mind H is inside of this parentheses, if I move this to +2, it actually moves to -2. And so it does the opposite of what you want, and luckily your lovely teacher's name is Miss Holly, and she's kind of backwards. She's a little bit of a backwards person from what I hear. And so hopefully that ridiculousness will help you remember that H is backwards. So you can always think H of Holly, H like Holly, and Holly is backwards. So if H is negative, then I would go towards the positive numbers. Okay? So let's get that down in here. So we are going to, when H is positive, you would think that it's going to shift to the right, but instead it shifts to the left. And again, this is a horizontal shift. And this is going to affect your x values. Just Like when it is negative, it goes backwards and it shifts to the right. Again, horizontal shift and affecting your x values. All right. So what's kind of cool with this is based on what h and k are, you can figure out where that vertex point is going to be. So if I want this vertex point to land at 4, 2, you know what, let's go this way. Negative 4, 2. If I want it to be at negative 4, 2, if I want my vertex to land right here, I'll even put a point right there. Okay? If that's where I want it to land, I know that I'm going to have to make my h go to positive 4, and my k value will go to 2. And then that is where it will land, even though it's a little bit, I mean, the graph is a little goofy on this guy, and it's a little bit off. But it should be it. It's regular 4, 2. Okay? So very, very cool. And the beautiful part of this is it is consistent for all functions. So as long as they are written, this is called a vertex form, because you can easily tell what the vertex is. This is also true for absolute values. H moves backwards from what you think it will do. And it is true for your k value, makes it move up and down like you would hope that it would. And even for square root functions. Your h value will shift this the opposite way that you think it will. And k is up and down, just like you think it will. And every other function you come across, which is really, really neat, has this vertex form. So, not a lot to memorize. It's one thing for all functions, which is really, really nice. Then, if we look at our a value, let's check out a next. And it's a little bit easier to see, I think, with this function. But remember, all of these are going to be the same for everything. A value, if I make this higher than 1, so if you look at your note sheet, your a value is chunked up into 4 sections. We know that from your activity that you already did, that when a is negative, it's going to reflect it over the x-axis. Okay? So it's going to do like a horizontal line of symmetry, blah, blah, blah. Our a value, when it's positive, though, when it becomes greater than 1, what happens is it increases here. And you can think of it like slope. Okay? So, like, if a was your m value for y equals mx plus b, this would be a slope of 2. So if we're going from here, I go up 2, and I go over 1. And there's my next point. Okay? So this is like your slope value. So as it goes up, we call this a vertical stretch. It's like you're stretching this function out, making it more and more narrow. So when a is greater than 1, we have a vertical stretch. Okay? When a is in between 0 and 1, so think about what happens when you have a slope of like 1/4. If I go up 1 and I go over 4, I'm going to anticipate my next point being around here. So 1/4 is like 2.5, even though this is going by tenths, so you can kind of get the idea. Right? So it would be like right around in here. Right? 2 to 3. That's exactly what's happening. So it's making it wider and wider and wider. And we call that a vertical compression. So it's like somebody is pushing down on the graph. It's compressing the graph down. So this is a vertical compression. Okay? Likewise, I hope that you kind of see this guy is the same scenario as this guy. He's just the negative version of it. So what happens is when a is negative, it flips it, but it still does the same thing. So if we start off at -1 and we go, we have that nice negative, ooh, hello, that's fun, woo! Sorry guys. We have that nice 1-to-1 slope going on here. If I make it something like 1/2, we would think that it would be 1 and over 2. So there is my 1/2. And look at that, that's my slope. So again, that in-between section is going to be a vertical compression. Okay, so it's going to be a vertical compression. And likewise, when it's lower than -1, so if it was like -7, it would be a vertical stretch. But on top of that, it's going to be a reflection as well. So two things are going to happen to your graph, which is kind of cool here. So if I make this, go back to our nice little -1, and then if I pull it more, it becomes stretched out. Okay? So not too bad. Nothing too terrible. Let's go back to our good old our regular old 101. So here's the deal. Our B value is the weirdest. It's kind of the goofiest thing that happens. Okay? Since A reflects things over the x-axis, our B value reflects things over the y-axis. Because there has to be something similar that goes towards it. So let's look at the square root function first. Because it's the easiest to see this happening. When we make B, and I don't want you to worry about too much, like this is going to change the slope also, and we'll look at how we're going to deal with that. But what I want you to focus on is if it's positive, it's staying in that first quadrant, it's going up and to the right. If I make this negative, that's that reflection over the y-axis. So it goes from being over here to being over here. So it's going to reflect, and it's going to go up and to the left instead. So that is the swap there. And then what's nice about the square root function, because you can control A and B, I can make it land in any quadrant. A lands it down there, both of them negative lands it down there. Okay? And we'll draw a little thing on one of your problems to kind of show you something that might help you with it. Okay? So that one's really easy to see. The problem is, what about the square root function, or what about the absolute value function and the parabola? If I reflect this over the y-axis, what's going to happen to it? So right here I'm going 1 to 1, no big deal. If I make this -1, it's the exact same function. Nothing has changed here. So because what's the absolute value of -1? Well, it's just a +1, so it doesn't actually change anything. Where you will see a change occur is if we're not at the origin. So if I'm at a 2, and then, I don't know, let's go to like -1 here, and then I change B to -1. So keep in mind, our point of it, why do you do this to me? Chill out, machine. So I'm at -2, 1 for my vertex here. So if I change this guy to be a -1, now I'm reflected over the axis. But there's a way to deal with this so you never have to worry about B unless it's a square root function. And I am going to share that secret with you. And if it confuses you a little bit, it is okay. We are going to practice it. Okay? And we're going to look at it more together. So what we're looking at here is, and I'll do it as a square root function instead of an absolute value, just because it's a little bit easier for me to type. If I have the function f of x equals -3 x minus 12 squared. Okay, that's my function. Right now my B value is a little goofed up. What we have to do is we have to factor out the B value. Okay? And so what we would do is we'd have -3 factored out, so that leaves us with x plus 4, right? You're factoring out a negative, and a negative makes a positive, and then it would be squared. Well, since the -3 and the x plus 4 are being multiplied together right here, we can actually distribute that square so that we have -3 squared times x plus 4 squared. And you can evaluate -3 squared. -3 squared is just 9. And it probably helps if I make this a plus and not an equal sign. So that just becomes 9 times x plus 4, sorry, this is goofy, squared. So we just changed our B value into an A value because now it's outside of the square roots. Okay? So you can eliminate B values because any negative squared becomes a positive, and the absolute value of a negative value becomes a positive. The only problem is you can't take the square root of a negative. So that's why this one is its own scenario. So we are not even going to deal with b values for our first two functions. You are going to factor them out. That is super, super important. Okay? So let's, and so when I ask you for your a, b, h, and k value, I want this value for your h value. Okay? B should always be 1. So let's take a look at a couple problems on the back. Go ahead and flip over. This is the third one, so I'll sneak backwards. Here's our first guy. First guy, absolute value, and they want to know what a, b, h, and k are. So write in order a, b, h, and k, but since we have a b value here, we need to factor it out. So if I factor 3 out of x minus 2, when you're factoring, you're dividing. That 12 turned into a 4 because I divided by 3. So this is just 2/3. Do not freak out too much about fractions. You'll see a couple with them. Not a big deal. And just think about when you distribute this back, I would get 3x, and then I'd be multiplying by 3 and dividing by 3, so it would cancel out. We'll practice this. It will be okay. So once I factor this out, I can take the absolute value of 3 and the absolute value of x minus 2/3. And I know that the absolute value of 3 is just 3. And 3 times 3 is just 9. So I've changed my a value into 9. And now I've changed my b value into 1. I'm only multiplying by 1 here. So a, b, h, k. A is 9, b is 1, h is negative 2/3, and k is negative 3. Then we want that point of inflection, that vertex point to plot, okay? So our point of inflection is always going to be 100% of the time the opposite of whatever h is, and then k. That's our point of inflection, okay? So our opposite of h is positive 2/3, and k is negative 3. Because remember, Miss Holly's backwards, so that one gets flipped. You can plot this point. I go over about 2/3, I go down to 3, and boom, that is my first point. The next thing you need to pay attention to is a positive or negative? If a is positive, you know that it's going to have a nice positive v here, okay? If it was negative, then you would flip it over and your graph should look like this. We know that we're dealing with this guy, okay? So remember, a is a lot like slope, so I can go up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I can go over 1. There's my point. And then since I know it's an absolute value, I should do the same thing in this direction. And then there are my 3 points to graph. Okay? So, because I'm hand drawing this and it's a little rough, we are just going to do this to make it a little bit easier to see. And it won't be a super curly, gross line. Like that. Okay, make sure you got arrows on the ends there. It does go on forever. Okay? Let's make a point here, obnoxiously big to cover up the fact that it looks goofy. Alright, so that would be perfectly acceptable. Not too bad. Let's flip to the next one. Our next one here, we've got A, B, H, and K. There is already, B is already 1, so we don't have to factor anything out. We don't have to do anything with that. Okay? A is negative 1/4, B is 1, H is 1, K is negative 2. So, point of inflection, opposite of H and K. So, remember opposite. Alright, so I can plot negative 1 and negative 2. Alright, now, it is a quadratic function, so we know that it's a U. And since A is negative, it needs to go upside down. Okay, so we're dealing with this scenario. And there is a vertical compression going on. That slope of 1/4 will widen our graph. okay? So let's look at this real quick. Because you're going to see the slope of negative 1/4, and you're going to want to go 1, 1, 2, 3, 4. So we think that there's going to be a point here at 3, negative 3. Hold on. It worked here because absolute value is a linear type function. But with parabolas, so we can graph this whole thing. Our h value is 1. Our k value was negative 2. There we go. And our a value is negative about 2.5. So remember that negative 3, 3? There's nothing there, okay? It's not a linear function, so it doesn't move in that manner. But what you can do is you can still think of it as slope, but it's 1/4 over 1. So whatever your a value is over 1. So if I go down about 1/4 and I go over 1, I land on my next spot here, okay? So instead of this being rise over run, whatever your a value is always your rise, and you always just throw it over 1. So I'm always going to go up or down that amount and then just scoot over 1 and scoot over 1. And then those are going to be my 3 points, okay? And if you want to plug in some values and you want to make a table, you are more than welcome to make a little bit more of an accurate graph. But that's perfectly enough for us, okay? So, last one. Flip on to the next one, because it's on the same page for you guys. Here we have a lovely square root function. We've got a, b, h, and k. We only want b to ever be 1 or negative 1. And since we have a 25 here, we've got to do something with it. So we're going to take that 25, and we are going to factor it out. And it works out nicely. 25, so 100 divided by 25 is 4. And then look at this. Square root of 25 times the square root of x minus 4. Oh, how convenient. The square root of 25 is 5. And then that changes our b value into a positive 1. So my a value changes to 5. My b value is a positive 1. H is negative 4. And k is negative 1. I don't know why some of those are dots and some of those are equal sign, because Miss Holly's crazy. Alright, almost done. So, same deal, point of inflection, POI. Our POI is going to be the opposite of H, positive 4, and K, negative 1. So I'm going to have a point at 4, negative 1. And then we've got to look at A and B. They're both positive. So there is no reflection going on whatsoever, which means that we're going to go up and to the side. So again, this is kind of slopish. It's going to stretch it up 5, 1, 2, 3, 4, 5, and over 1. And for square root functions, honestly, you can just use 2 points. Okay? That's going to be the norm, because they don't have the double-sided going on here. Okay? The last thing I want to show you, just so that you have it specifically for square root functions, is when you have the square root functions, you've got your a value and your b value. You have 4 scenarios going on. You can be going in this direction, this direction, this direction, or this direction. And this is a picture we're probably going to draw a lot. Okay? So this guy is positive A, positive B. Remember that A reflects it over the y-axis, so this is where your A is going to be negative, but B will still be positive. Okay? B value reflects it over your y-axis, so A is still positive here, but B is negative. And then to get down into the third quadrant here, they both need to be negative. Okay? So something to kind of help you with those guys. We're going to practice these a ton. And if you need to kind of rewatch this or whatever, please do so. I hope that the visuals of Geometry Sketchpad really helped you, and feel free to email me if you have any questions.